So let's look at another way to use FBX with Houdini, and that is to import it as subnets. This is also the way to go if you want to use the bake shelf tool, which we're going to use in this section. And by the way, I want to thank Centroid for helping me out and capturing all the mocap for this and some upcoming videos. And why would you want to do this instead of just pointing to an FBX? One of the reasons, at last if you are a generalist, could be that you want to tweak the asset. Okay, so let's start by going to File, Import, and FBX. And then I'm going to select this REST FBX out here, accept, and I'm going to do merge, not import, otherwise it's just going to create a new scene. So here's that one, and as you can see, it's converted this FBX to subnet. So in here we have these 5 pieces of geometry, and then we have the skeleton of the agent. So what do I want to do with this agent? The first thing I want to do is I'm going to go in here, and if we look at the amount of polygons, I want to reduce these guys. And this, of course, is not something you would do at a bigger place, because the asset department would handle that. But if you are in a smaller place, it can be quite handy to be able to do sometimes. So poly reduce, and then I'm going to put it down to 50, and remove this triangulate, and also stiffen borders. And this might be a bit coarse, but if I'm going to see them from this distance, it doesn't really matter. I'm going to drop down a normal, and then I'm going to set these to points, and then I'm going to copy this, and do this to all the different geometry pieces. And by the way, you always need to do changes like this before the deform, otherwise it won't work. And last one, like so. So now the geometry is reduced. So another thing I'm going to do, because I want to have as few bones as possible, so, and I'm going to use the option minimal nodes, which means that any joints that isn't attached to a geometry and is hidden will be disregarded. So in this case is what I want. In this rig, like most of the things are hidden, but for some reason this right toe base bone is not hidden, and I don't want to have this bone. For the left side, I'm going to do the same thing. And then this thing here is that this rig has an extra joint for the prop in it, and you will see in the mockup later that we have a solved prop, which is always preferable than just attaching something to an agent's hand, because you get a different kind of motion. But in this case, I don't want to have this staff bone, but I will save this staff tip. If I save the staff tip, I will get this staff base too, because this is dependent on the staff base. And if I would hide it, then I would lose these two guys, because they are not attached to anything, because they are just for the prop. So like so, because this will be what I'm basing the rig on, so I'm going to call this red. So red, like this. And then I'm going to click Bake Agent. And first here, I need to tell what the agent is going to be called. I'm going to call it Warrior, and then I'm going to call the clip Rest. And here, then you get this dialog box. As you remember, when we're setting up the foot planting, we set up this chop network. And this dialog lets you select whatever you want to be included in that chop network, and then it will just set it up for you. So I will select the left foot, and I will select the left toe base, and I will select the right foot and the right toe base. So the right foot will be the ankle. I accept. Great. And now you can see it's created 2 new nodes. One of them is the ROP network, where everything's baked out, and the other one is just for testing what you just wrote out. So this is just an agent sub reading back what you just wrote out. And yeah. So, but if we go into this ROP network first, here is the chop network. You can see here are the joints I selected in the dialog box, and it's for this rest clip. And then here I'm gonna change some of the default settings. So this is perfect. It's pointing to this subnet. Minimal nodes is what I want. Convert to polygon soup, and I definitely want locomotion, so I'm going to select this, and I'm going to select the hips, because in this rig the hips will drive the agent forward. So I'm going to select the hips, I want to save out the rig and the agent layers, the shape library and clips. Perfect. Yes, nothing to change here. Perfect. So let's import some mocap. Okay, let's import some mocap. So I'm going to go to import FBX again, and I'm going to select this first walk idle and merge. You can see we have this guy from idle, and it starts walking. So that's perfect. And then let's import an alternative. So I'm going to import FBX again. Going to go down, and I'm going to select the other walk and merge again. We can see that we have another walk, but this time it's holding the prop with both his hands. Perfect. So let's use this. So I'm just going to put this guy up here. So before I bake these guys out, I need to make sure that the rig is the same as the other one. So that means I need to go in and hide these bones again, like so. And in this one too. Hide, and hide, and hide. Okay, perfect. So now I'm just going to go and click Bake Agent here again. And get this dialog box. So it's very important with the name, of course. It has to be Warrior. And now it's Walk, because it's one of them. They are holding one hand. I'm going to call it Walk 1H for one hand. Accept. And then I need to have the right foot and right toe base, and left foot and left toe base. So accept. Let's select the other one. Click Bake Agent again. And I'm doing the same procedure. And I'm going to call this Walk 2H for Walk 2 hands. And once again, I need to select the ankle, which is a foot in this rig, and both legs. Looks good. Accept. So let's see what this gives us. If we go into the ROP network, you see that now we have 3 agent ROPs, 1 for each clip. And if we go into the chop network, select this and press L so we get them lined up, we can see we have 3 shop networks. But once again, we need to go in and change, because first of all, we just want these guys to write out the rig. So if we select both these guys and goes to the bottom, I'm going to uncheck everything except the clips. And then the next thing you need to do is that you need to convert to in-place animation. So I'm going to select that, and then I'm going to select the hips for his subnet. And I'm going to go to the other one and do the same thing. Hips, and once again hips. So, and that is all. So if I just click here and render, or I can go to the top and click bake, now everything should be written to disk. So let's go in and see if that is true. Let's go and reload this and see. Current clip, we have walk 1H and 1 2H. And it seems to work. Let's see if the locomotion works. Yes, we can see he's in place, and if I check this, apply locomotion, we get locomotion, and we're just going to try that for that one. Same thing here, same thing here. Great! But before we do anything else, let us just revisit the topic of foot planting. So let us talk some more about foot planting. So I have these two guys, and the blue one's ankles are locked for a shorter time compared to the red ones, whose ankles are locked for a longer time. And as you can see, the longer ankle lock completely ruins the animation. So if you want to take away one thing from this, is that you should always be conservative with the ankle locks. Let's turn this off, and turn this guy on, and then go into the bake, and then we can have a look here. So here is the left foot planted, and as you can see, here already, it's actually not planted anymore. The toe, on the other hand, of course, you want that to be locked through its whole thing. So you can see the toe is not unlocked until there. So it could even go a little bit further, but I find it even here it's better to be a bit conservative, so here it's gone. One thing I find sometimes that with some clips you want to accentuate the heel coming down, and in this case you can see that it's not really working because here's the heel coming down here and it's not even close to be locked yet. But then at the same time I don't want to drive this value up to like a crazy number, so it gets locked for a longer period of time. So what I usually do when I have, in this case it doesn't really matter, I think it looks okay anyway, as you just saw in the comparison. But if you would want to accentuate and be sure that that ankle is coming down ahead of time but still have it unlock pretty quickly, what I usually do in these situations is I drop down the delay. So that is basically making you move around the curve, and then I am adding a math and combining these two guys. So, and then I do combine chops, maximum, and then I go to, so say that we want it to be here maybe, and then I would look at this one, maybe drive this down a little bit, even less. I would use this delay to position it. So now I have the curve that is coming down here, but still it gets released pretty quickly. It's depending on what kind of clip you have, because it's chops, you can manipulate the curves however you want, so just remember that you have this option as well. And I'm going to delete this here now, and if we look at the run instead, runs are usually more forgiving. The ankle is even less important for those guys. So if I would look at this, and I would maybe, well, I mean this is not too bad, but if I would say I would take this to 0.2 or something, and then you can see there's actually be steps when you don't have any ankle plant at all. So walks are a bit more fiddly, so you need to be more careful about those. Runs are a bit easier most of the times anyway. We have all our foot plant channels, but as you remember, we need to set this up first for it to work in the sim. So let's do that before we do anything else. So go down here to lower limb in agent prep, and then we're going to set up the IK. Left up leg, left foot, left toe base, and then we're going to set so we're going to left foot planted and left toe base planted, and then we're going to set up the other one, and now it's right. Now it will be right up leg, and right foot, and right toe base. And of course the right foot planted and the right toe base planted. Okay, so perfect. The one thing we can't forget is, as you might recall, we obviously need to set up the offsets so we don't get the heel going through the ground, as we saw before. So let's do that. I'm just going to go back to smooth shaded, and I'm going to drag this. This is okay. And for the toe, and there, and there. And I'm just going to copy this. Copy these values and minus. So let us give this agent some layers. So we're gonna do like we did before. I'm gonna drop down an agent layer, and as before I want it fresh, so I don't want it based on anything, even if I could. So let's look what I want to do with this. I want to add each of these pieces of geometry, and then I want to add them under this warrior null. It doesn't really matter that I'm using this as a transform, because the geometry pieces, they are deformed by the joints anyway, but I need to put it under something, so why not that? So if we go in here, and I'm going to start and call this with helmet, because I'm thinking I'm going to have one variation with the helmet and one variation without the helmet, and it's going to be 5 pieces, so here are those. And like I said, I'm going to put them under warrior, and then I'm going to put them under head, warrior, helmet. See, he's getting built up here. Warrior, body, warrior, fur, warrior, and this fur, I probably should just remove this from the crowd agent, but let's just keep it for now. And arms and back. So here is our first layer. The layer name, I'm going to do what I did before, $OS, so it just takes the node name, and then I'm going to copy this and call this without. And then I'm just going to go down to the helmet, so here, and I'm just going to remove it. So great, so now we have two. We have one with helmet and we have without helmet. So the next thing we're going to do is to give this agent a prop. As you might recall, this is a solved prop for this mocap, and you have this extra joint in the rig that you can use to transform a prop. So let's try that out. So if we go to this helmet guy, I'm thinking we're going to give him a staff, because it's very simple to make. So I'm going to drop down a tube. I'm going to make this to a polygon. I'm going to make the scale quite thin, and up the height a little bit. And then I'm going to call this staff. Let's go to this guy here, and we're going to add an extra layer binding. And this time I don't want to use the warrior as the transform name, because now I actually want to transform this geometry with a joint. So therefore I'm going to select the extra joint, which is staff base in this rig, and then I'm going to check this add shape, and I get an option for a sop path. So I'm going to point to the staff, and we still don't see anything because we need to give the shape a name. So I'm going to call this staff. So here is our staff. And the position is obviously wrong, and the reason for that is just because this key position when attaching was checked. But we can just go in here in shape transform and zero everything out, except the scale, because that is actually the right scale. And now we can see that the orientation for the staff looks pretty good. The grip is a bit high though, so let's change that. I go back to the staff and then go into the center here, and then just move the center, something like that. If we look at the animation, we can see that the staff is now following along. Perfect. You can see that the staff is not only attached to the hand, because you get a different type of motion if you would do that. Sometimes you need to do that too, of course, because you might not have a solved prop. Let's just set that up and just show the difference between a solved prop and just attaching it to the hand. So I'm going to copy this guy here. I'm going to go to start here. And then this time I'm going to use this key position when attaching. So I'm going to just make sure that I'm lining this guy up correctly. And so I'm going to put down a transform. And I'm going to rotate it. Something like this, maybe. Something like this. Yeah, it's alright. And then let's go here to this guy, and then we're going to remove the old layer and just do it from the start. So I'm adding a new layer. I'm going to choose the right hand this time. Add shape. And I want to have the transform, so I'm going to point to that transform. It would be nice if I just made it null, but let's point to this transform, and then I'm going to call it staff. And just because this key position when attaching was checked, it's just copying that position. Now you can see that he's walking and he's attached to the hand. And you might notice that the motion is quite different and the stuff feels very lightweight. And just to show it a bit better, let's merge these two guys together. Solve one and the new one, and then I'm going to drop down a transform and just move the other guy back a little bit. So if we look at this, just look at the motion of the staff. This one have more weight to it and it looks much better. And of course, if you have a crowd from a very far distance, you can probably get away by attaching it to the hand. But always try to get the motion as good as possible. But yeah, that is how you are adding a staff to your agent. So let's create some clip properties for the two walks that we have. So let's start with the first one. And I've just selected the agent stop here. And let's see, it's going to just stop. So around there, 173. It's going to drop down property. Clip property. I'm going to do the first. I'm going to do loop range 173. And let's see, let's stop at so 349, and then I got to put the blend, and then let's do the other one before we do anything else. So walk 2H 118, and 268. Okay, so let's try these two. Test crowd. It's very convenient to have this little sub. So first it's freaking out, so let's select the clip, and then here we see we have the loop, we have the little slide here, so let's see if the footlocking is going to solve that. And it seems fine. Perfect, so let's try the other one. Go to 150, so around here. Here we see we have the loop. Let's see if the footlocking is helping us. And it seems fine. Perfect, so now we have our, I can delete this guy. Before we do anything else, I'm going to do this. Out properties. Cool, okay, so now we're ready to start using our agents in a real crowd. Okay, let's make a crowd. So if we go out here, the first thing I want to do is to get the environment. So I'm going to drop down a geometry sub, go in here, and I'm just going to load this terrain. And here is the environment we're going to use. My goal is I'm going to use this part of the environment. So I'm going to have a little crowd here, and I'm going to have it running and walking through this. So the first thing we need to do is, of course, to create a layout for the crowd here. So I'm going to call this terrain. And then I'm going to drop down a new geometry, which I'm going to call crowd source. And I'm going to call this yellow, so I can find it easily. Delete this one, and then I'm going to drop down a grid. I'm going to move the grid over here, and this grid is what I'm going to use for generating. I'm going to use this to generate a crowd. So I'm going to cover the area like this, and I'm not going to use the built-in. I'm going to scatter points myself. But one thing you see here immediately is that you get all the points scattered in this really boring square, so we don't want that, and I don't want as much agent either. So what I'm going to do is I'm going to go back to this. I'm going to up the resolution a little bit. I'm going to drop down a paint, and then I'm going to go to background, apply all, so everything is black. And then I'm just going to paint this where I want the crowd. Something like, I can actually move this down a little bit so we can see better. Just want to break everything up a little bit. Something like this. And then if we go back to scatter, nothing happens except that you can see that the points has the same color as the color attribute. But what you can do is go in here to the density attribute. Still nothing, I got an error because there is no attribute called density, but what we can do is just to rename this to CD. And suddenly you can see that this is following what we painted. Great! So let's drop down the crowd. So the first thing we're going to do is do an object merge. I need to get the agent, so let's go to the warrior setup and out. And now we have the agent here, and then I can drop down the crowd source. Something like this. And here is our crowd. What you can see is that the agents are taking the colors from the scatter, and I don't want that, so I'm going to delete the color again. Delete and delete CD. Like so. Gray and beautiful. So here is my crowd, and all the agents are facing the same direction, boringly enough. As I'm going to use a curve to steer them through the environment later, I can use this very same curve to orient them on the starting frame. So let's start by dropping down a curve. And then I'm going to turn on snapping, and I'm going to get a better angle. Something like this. I'm going to start laying out the curve. Something like this. So what I want to do now is take the tangents of the curves and orient the agents. So first thing I want to do is create an attribute that contains the tangent. And I can do that with a polyframe. I can see by default it's creating the attribute tangent U. And if we visualize that, so if we visualize this, we can now see the tangents of the curve. Perfect. So let's delete that. And I'm going to drop down an attribute VOP. I'm going to drop this before the crowd source. So with the crowd source, if you add attributes to the points that's going into it, it will use that for the crowd. So as you might recall from before, the state is a string variable, so you could put that on the points, and then this crowd source will pick that state up. So in this case, we want to set the orientation before it goes into the crowd source. So let's drop down this attribute VOP here, and in the second port, I'm going to put this curve. So let's go in here. So what I want to do is that I want to take the different agents, and then I want to check the closest location on the curve. You can do that with an XYZ dist. And I put the curve in the first port here, and then I take the point positions of the agents and put that into the position port here. So what you get out here is the distance to the primitive, you get the primitive number, which doesn't really matter because it's a curve, but if it would be in geometry, you need to know the number of the prim, and then you get the UV of that primitive. And to use this, you can use a primitive attribute. And what this allows you to do is to take a geometry, and then get the primitive in the UV, and then read the attribute at that location. So by default it's CD, but we want it to read tangent U. So now I have a vector. So as you recall from a previous video, you can use a normal to drive the orientation of an agent. So let's plug that into the normal. And let's go out here and let's see what we get. And we can see that it's working, but they are facing the wrong direction. It's the opposite of what I want to do. So to solve that, I'm going to multiply the normal with -1. Multiply constant, and then -1. And now we can see that they are facing the right direction. And we can also see if we would add a guy, we can do that by just dropping down a point here and add. Now we're going to drop it over this guy. And then we're going to drop down and merge. Like so. And then if I just take this guy and move him here. And you can see that he's changing the orientation based on where I'm placing him. So, yeah. So let's put together a crowd sim. The first thing I'm going to do is just to clean this up a little bit. So I'm going to drop down a null for out agents. Make that black. And then I'm going to have one for the curve too, because I'm going to use the curve in the sim, so I want to be sure that it's easy to select the curve. So I'm going to do out curve. So awesome. And this time I'm going to drop down the dop sim outside. So I'm going to drop down a dop network here in object mode, and I'm going to call this crowd sim. And let's get in here. So we need the crowd solver, as you might recall. We need the crowd object, crowd source, and we also need the crowd state. So, okay, so first for the crowd object, the thing we need to do here is to put in the clip properties. And as you might recall, those will be in the warrior setup. So out properties, excellent. And then we go to crowd source, and here we want to use our out agents. That is perfect. And then for the crowd state, we're going to call this walk. And I want to randomize the clips here. So I'm going to select this randomize clips. I need to go to the first frame because otherwise you won't find the clips. I go to the first frame and I can take, there's one, and then there's the second one. And everything is broken now because the crowd source is not specifying any state. Let us just fix that by going to the crowd source. And here I'm going to do initial state. I'm going to call this walk, and like so. And I'm going to turn this off actually because we don't want to see this. And excellent. We can see that we have a mixture. Like some of them have only a one-hand grip and some of them have the second two-hand grip. Perfect. I also want to change this to locomotive. Very important. And I want to change, I don't want them to walk in the same speed, so I'm going to put up the variance a little bit, 10%. And then I'm going to do the initial clip time and the clip offset. I'm going to make that to 4 seconds. So this is a good start. And then other things that you always need to do, this project forces should always be on. So I'm going to check that. I'm going to leave the avoidance. I'm going to add the terrain just in a second, but for now I'm just going to have it like this. I haven't added the curve here. The one thing you might notice is that now it seems to have to change the orientation again, because before they were oriented like this. If I go and add this as an overlay, you can see they are not facing the same direction, and that is because it's using this initial velocity and heading. So I'm going to just kill out the initial velocity. We can actually kill out the heading too, because now it's using, if there's no heading, it's just going to use the normal as heading anyway. So that is better. Now you can see, at least it's starting walking in the right direction. And then why they start moving out and going all these places is just because of the avoidance. Before we add anything with the curves, of course we don't want to have them floating like this, because now they're not connected to the ground. I'm going to turn off the grid here. And actually I'm going to do another thing too. I'm going to go into the terrain, because it's a bit hard to see now, and I'm just going to drop down the color and do what we did with the feet before, and make this some kind of green. So now it's a bit easier to see what's going on. But as I said, we don't want them floating. So you would think that the best way would just be go in here and take the terrain, enable terrain projection, and then select the environment. And it does work. But one thing you will notice now when I start playing, it is extremely slow. So before we start making these guys following a curve, just let us look how we can fix this slowness with height field. So let us fix this slow height field. There's actually two ways we can do it. So I'm going to start with one. So if we go in here and create a height field, and then I'm just going to match it roughly to where they're going, something like this. And then from this, I'm going to do a height field project. And you don't get all of it, and that is just because it's raycasting in just one direction. So let's move it down a little bit. Now you can see get everything. I'm gonna get some more detail by lowering this grid spacing. So put that to 1, and now we have some more. If you use this would be really fast. So if I'm just pointing to this height field and play it, you can see that this is much faster. The problem though is that there is one feature that we haven't talked about, and that is the leaning in the terrain adaptation. And we haven't talked about it because we haven't set it up before. But so let's set that up and just show what that does. So the whole thing with this leaning is that when the agents are walking up a slope, they are leaning a bit forward, and when they're going down a slope, they're going to do this backward lean. It's going to do a minus 10 degrees there and a forward lean of 60 degrees. And here this lean angle per frame is just how many degrees an agent can change per frame. So to get this to work, we first need to set it up in agent prep. So just as with the legs that you have to set up an Ike chains with the legs, you need to set up this torso chain for the leaning to work. So specify what is the spine and what is the head and so forth. So you can see hips, well, that's the same thing. Lower back will be spine in this rig, and head will be head. So now I've set up this torso, and of course, like I said, it won't work with the height field, so let's just change that back so you can see the difference. So if we go and select the file again, you can see that everyone is moving a bit forward. And because it's just moving 2 degrees, when it's walking, they're going to rotate more and more. So, but if I set this to a high value, like 300, then you can see the difference a bit clearer. So if I turn this on and off, and if I turn the height field on, it's going to be removed. If we're not going to use this feature, the height fields is quite nice, and they are easy and they are fast. But if you're not using them, then you can use this other method instead. It's quite similar. The only thing is, instead of a height field, I'm going to drop down a grid. And as with the height field, I'm going to specify it like this. I'm going to move it up a bit, because I'm going to raycast down on the environment. And then I'm going to put this to maybe 300 times 200. Like so. And then drop down a raycast. For direction, I'm going to use vector, and then I'm going to delete this and put this to -1. That is my direction. And I don't need this. I can get it in a bit side. So now it's raycast over this, and then as with height field, you just point to that instead. So go in here, and I'm going to point to this ray. As you can see, it's still much faster than before. And now you're also going to have the leaning. So I'm going to take this down to 2 again, and then I'm going to go out and let us see the terrain instead. So now let us add the curves to the simulation. Moving on, let us add some behavior to these guys. Currently they're just like spreading out and they don't really go anywhere. They just go forward. Let us make them follow that curve that we made before. So in crowdsource we have this curve. So let's use that one. So we're going to crowd sim, and then pop zero path, and then I'm just going to point to that guy, out curve, and I'm just going to leave everything as is. The only thing I'm going to do actually, I'm just going to go, because currently we just have this walk that is quite slow. We will add a run later, but for now, let's just double the speed of this guy so we don't have to wait as long. So like so, and then let us just simulate some frames. So yeah, looks fine. By the way, if they are not following the curve, it's probably because that you don't have these project forces checked, so just remember that. But here it looks fine, and the only thing is that this little bump here is a bit extreme, so I'm going to make sure that these guys are not going over that bump. And I'm going to do that by dropping down a geometry sop, and I'm going to call this obstacle, and then I'm going to go in here, and I'm going to drop down a sphere. I'm going to make that a polygon mesh, gonna make it quite big, something like this, and then I'm gonna drop down a transform, and then we're gonna move this guy, move him down a little bit, just move him over here, something like this, like here, and then why not make it for this little thing down here too. We're gonna copy this, I'm gonna move that guy, something like this, and then I'm gonna merge these guys together. I'm gonna make it null. I'm gonna call this out obstacle, out obstacles, and color this black. And if going to the cross sim, I just need to drop down a pop steer obstacle and point to these two guys, which are, let's see, obstacle, out obstacles. So let's see how that looks. And here you can see, might have made it a bit too narrow, but you can see that they are trying to avoid the obstacle and go in here instead. And this little guy here is clearly not working, but well, in this case I might change it a little bit just because it's a bit too narrow. But if you are happy with the overall feel of the crowd, it's usually better to just delete the guys that you don't want, because if you start changing everything, then it might be that the overall simulation doesn't look as good, even if that guy is not walking around here anymore. So always delete them. Another thing we can talk about is, you can see right now they're doing quite an aggressive turn, and that is because this max turn rate in the orientation update. If I put this down a little bit, then they of course are going to be harder to control because it's going to take them longer to orient themselves. So now you can see we have these two guys are not really doing it. So let's keep it for here. The overall rule is that the further away, the higher turn rate you can have. The closer you are, then you're going to see the actual motion a lot more, and then you would want the lower max turn rate. Just something to remember. So I went back and moved one of the obstacles a little bit, and in that way we got a bit of a more natural result. You have a narrow passage, but they're expanding a lot quicker. Okay, so I've added some more clips to the agent, and just so you didn't have to see me do all the clip properties again, I just did them before I started recording. So I have two run loops. I have this one with one hand, and then I have the other one with two hands. And then if we go up to the agent and see everything that we also have this walk, run, idle, two in one hand. And what these are from idle to walk, and to idle again. It's great when you have this, if you mock up it this way, because then you're going to get very nice transitions between different states, because you have this perfect from walk to run, and just like the quality of the movement when they are going from, they do a little bit of an anticipation and start to leaning over, it would be much better than if you just try to blend two clips. So always try to get long clips like this, and then you can cut them up later. I'm going to actually add one thing that I didn't do when I was doing these two loops. I'm going to add an idle, and I'm just going to use one of the clips that we have. So we can take it from anyone actually. We can take the walk, this one. It's just standing here for a while. So maybe do like a loop between 108 and 24. So how would you do that? So you could use an agent clip load and just load it once again, but that is unnecessary because you have a feature in the clip properties that helps you to just create name alias. So if I create a new property here, and let's take the walk one hand first, and then I'm going to check this clip name alias, and then I'm going to call this idle 1h for one hand, and then I'm going to do the loop. What did we say? We said 24 to 108, a bit of a longer blend this time. And if we go down to this test sim now and select it, we have this idle 1h suddenly. So if we select that one, we have idle clips, and it's just created from the walk clip. Great. So let's do that for the other one. So let's see what range we can use there for the walk 2h. 22, 2279. New one. Walk 2h. Idle 2h. No, I don't really remember what I said now, but I think around 2280. Let's do that. And then do a 6 frames blend before and after. Let's try that. And go to the test sim and select idle 2h. So here's that. Yeah, it looks good. Perfect. So now we have 3 clips for each hand position. So we have the idle, we have the walk, and we have the run. So the only thing we need now, and we're going to look into in the next video, and that is how to create transition between these clips. So let us look at the transitions. And I'm not going to lie, this is the most tedious task that you can do, but you can get some very nice results from it. So let's get to it. So first of all, I'm going to drop down a transition graph, agent clip transition graph, and then I'm going to connect the agent here. And immediately you see I get all the clips that is associated with that agent. But I don't have the idle. And the reason I don't have the idle is just because idles were created in these agent clip properties. So I need to connect that to the third port. Now you can see this circle expands and you get the idle 2h and idle 1h. So what this is showing us is which clips are connected. And none of the clips are connected currently. Let's start with the idle 1h and let that transition into walk 1h. It's very simple to do. You can click the plus here. You have a clip A, which would be the idle 1h. And you have a clip B, that would be the walk 1h. And you can see immediately draw this line between idle 1h and walk 1h, because now these two have a connection, so you can travel between them. To make it a bit easier, you can click this show guide geometry, and here you can see this sync frame, what that is, and you can see what the sync frame of the clip B is. But what you can see here is this is not actually the first frame. This is just the first frame in the loop for the walk. If you would look at the full range of the walk, is of course, wait, sorry. It stands there and then it starts walking. But the reason we don't get that is because we created this loop property. There's two ways you can deal with this. One way is just to create an intermediate clip. You can either load it with an agent clip, or you can just do another alias here that you use as an intermediate. But what we can also do is that we can change the start frame, because now the start frame is the start of the loop. So let's just make it easy and delete this and put this to 0. So if we go back here now you can see there's actually the whole clip that we can go from. So first of all, let's find where we want the first transition. Usually just want to have like small transition windows with just one frame each. So let's start just with one at, and I usually do them like 1 second apart. Because the thing is, the more windows you have, the faster the agent's going to react to a transition. But then it's also going to take you time to set up all the windows. So I usually paste them with 1 second apart. So we take this, we're going to put this to 25, 26, and then here, let's find just before it starts walking. So it's standing. Oh, here it is. So around here, around 121, and then we can do 6 blend frames. Awesome. So now we have a first transition. So let us try that transition. So if you connect this in here and look at this, and now we have clip A, so we can have idle 1H there, and then we're going to have walk 1H. We know that the trigger frame is 25, so let it stay on 10. So you're going to trigger on 10, and then it's going to wait for a window that's going to be on 25, and then it's going to trigger it. So let's see if that works. Yeah. And look what a smooth and nice transition we have. You wouldn't get that if you were just blending between an idle and a walk. So once again, you always want to have long clips. And you can also see another thing here. You have this guide. When it's red, it's not triggered. When it's orange, then it's triggered, but it's waiting for an opening. Yellow, now it's doing transition. And green, now it's done. Yes, you can see here before, pending, during, and after. Awesome. So let's do some more windows, because you could see if I would set the trigger frame to 30. Now we just have one window. So you can see it there, it's triggered, but now it's waiting. And there the transition came, because it has to wait for the loop to restart and then to get its window. So let's do a couple more. So how big was idle? Let's see if we go down. So 75. So let's do 3 windows then. So if we do the next one, I click the plus here and do 50. Do 50 here and 51. And this, I'm going to use the same value, so 121. And then 6 frames. I'm going to turn off this guide geometry, it's just confusing now. And then we do the last one at 75. So 75, 75. 121 and 6. If we go back and do the same thing, now it's still at 30, but it's transitioned way faster because we have more windows. So next thing we want to have is a walk to a run.